Good day, ladies and gentlemen. You're very welcome to today's technical session of the CNPS, moderated by me, Ian Cowan. Now, today we are progressing further with the 8-part series of talks that have been prepared by Vladimir Netchitailo, and we're already into the second half, actually, of the presentation. So, in other words, we're dealing with part 5 of an 8-part series. And looking at it actually myself, it appears that Vladimir is homing in our own location. In other words, he was starting with sort of distant galaxies, and we dealt with the Milky Way, our own galaxy, and so on. And today he's going to deal with the solar system, actually. So it's all part of the Hypersphere, I suppose the non-Euclidean World Universe Model, WUM. We'll come up with that abbreviation later. Part 5, Solar System. And the intention today is to explain the main solar system mysteries, such as why does Venus spin backwards and Uranus is tilted sideways? Why is Sun's atmosphere hotter than its surface? Yes, that's a well-known phenomenon. How many unknown dwarf planets are out there? We've only in recent years started to look at all these and declassify things like Pluto, I suppose. Does the Oort Cloud exist? That's an interesting one. I look forward. I suppose I would have thought it does exist. How was the moon created? That's an interesting one. Did Mars have oceans in the past? That's a perennial point which has been raised. Was Mars itself hit by a giant cosmic lightning bolt? Why are planets so different in composition? Yes, very interesting question. Do Jupiter and Saturn even have a core? Good speculation. Why does Pluto have mountains? How big is the solar system really? So that's quite interesting, because this is a very fundamental physical theory which Vladimir has been going through, and he's been applying it to all aspects. And we dealt with the big question of angular momentum, I think 4 weeks ago. But we're now en passant, if you like, looking at some of the perennial problems that people have been asking about anomalies in our solar system and so on. And I'm actually quite intrigued if the WM is able to answer these questions or give a definitive answer to them in many respects. Okay, the questions are just starting to come in. So just to remind you, as usual, the format, and if any of you have any suggestions or any complaints, if you'd prefer done one way rather than the other, please submit them. They're all welcome. But generally, we have just under 2 hours available to us on this StreamYard, and we roughly divide it 50-50. So Vladimir would have an hour to speak. Now, we're not timing him actually to the last minute. If he wants to go over that by 15 minutes, that's fine. If he wants to stop 5 minutes short, that's fine as well. So we might have 3/4 of an hour, say, for questions and answers, and also discussions, because we have a number of people in the green room, and we normally like to limit that to invitations, because if people just start swarming the green room, they won't be permitted in. Actually, we have a maximum number of 10 that we can take in, but we only have 4 at present. So if any of you wish to come in, and I know people like Franklin, I don't know if he's here today, but he frequently asks questions through the social media, the Facebook and the StreamYard, and then he comes into the green room maybe if we have discussions. So we could possibly do that if some of you want to come in later and have a more detailed discussion. We'll try to deal with some of the questions first. And as I have said in the past, it probably doesn't really arise, but just theoretically, if there's any really urgent thing, it's like a life and death matter. Oh, the system will break up if he doesn't explain that word. You could come in and we could interrupt the speaker. We prefer not to do that, but I mean, in extremis, we can do that. So just indicate the nature of your correspondence, because a lot of you are corresponding between yourselves, which is quite acceptable. That's part of what the series is all about. But if you have a very specific question, you might just say this specific question for Vladimir, and then it'll make sure that I don't miss it. Okay. So that's fine. Now I'm going to have the pleasure of bringing Vladimir up again. And I think this is well rehearsed. You, Vladimir, as usual, I presume, have a written presentation which you'd like to project.
Yes, ma'am.
And we know how to do it. We've done it so many times, it should work. And the only thing is you bring it up. Well, you share your screen, and then I have to bring it up, actually. It's a two-stage process. And then I bring myself down. The floor is entirely yours. And then I even get rid of your photograph so that we maximize the screen. So if that's all right, I can do it again today.
Okay.
Fine. So if you'd like to share your screen, I should see the results of that in a moment. I think you shared your complete screen the last time, and you might have to press it twice, share screen and then share the little rectangle.
Did you see my presentation?
No, funnily enough, I'm not seeing it, which is odd. It normally comes up pretty smartly.
Okay, let me try one more time.
Yeah.
Okay, let me do it. It's not a big deal.
Right. I think you had to do it twice the last time as well. Don't know why.
Yes. I will do it. Don't worry. Present. Yes.
We're not showing the funding video now, which takes a few minutes because it's well into the year and they've sort of reached their goal. So that's the end. So we have a few more minutes. There's no mad rush. No, not seeing. Don't see that.
One sec.
Because I don't know. The other way is to share your slides and have the slides maybe on the desktop. But I think
I'll do it. Don't worry.
Well, you've succeeded 4 times in the past, so I don't see.
Yes. I don't know what's going on today, but it will be okay.
You forget from week to week, and there are minor differences. As long as your connection is excellent from California. And thank you again for getting up at such an unearthly hour on a Saturday morning.
Okay. Unbelievable. One sec. Sorry for.
No problem. Take your time. Do it slowly.
Yes, I will. I don't know why my laptop today doesn't want to listen to me.
Yeah. It might be being censored by the gremlins or whatever.
Maybe, who knows?
Well, we were sometimes cut off when we might have said a word which was very unorthodox, and suddenly we're cut off. We said, "Oh, there are the, the whatever you call it, the people who are watching us. The censors. They're stopping us." We used to feel a bit paranoid, but I think it was mainly joke. So Vladimir is gone now. Oh, he's back. You went there for a moment. I don't know why. But I think maybe the options are either to share your screen or to share your slides as a file. You have 2 options.
Okay. What the hell is going on today? Why does it want to go, man? I don't know. Shit.
Yeah. But by the way, if all else fails, you could send the file.
No. Yes, I know. I can't, but I prefer to have in my hands.
Indeed, so do I. Yeah, because otherwise you have to tell me next slide, move on.
Yes. Unbelievable. What the hell is going on today?
What's happening when you try to share it? Is it giving any response? Is it giving an error message, or is it just doing nothing?
No, it doesn't want to go. And that's it. For some reasons, my file, it doesn't want to go. I don't know why.
Yeah, well,
Share.
you've done it before. You've done it before, Art.
Yes, many times.
Right.
Let me.
He's logging out and then logging in a bit. So, ladies and gentlemen, I just beg your perseverance in this. It's a little teething problem. We should be able to solve it out without any great delay. I see you've logged out and logged in. You thought that might resolve
Yes,
the matter.
many times, but unfortunately, share screen, I put it, window, and now I want to put my file in here, and it doesn't want to go.
I think you're better, Vladimir, if I may say so, sharing your screen rather than sharing the file.
Sharing the screen, I put it sharing the screen.
Oh, did
and
you?
then
When you press sharing screen, he's gone now. If he's back, I'll tell him. Yeah. If he comes back, because there's a banner at the top. You have to share your screen, but then you have to say what? Entire screen. Yes, you have to click that. The questions are coming in, Billy, already. A lot of points about Pluto and the moon and Mars and so on. So no doubt there'll be some discussion on those aspects after the lecture.
I'm sorry.
Vladimir, I don't want to, you probably know all this, but when you say share screen, that's not enough. You have to go to the top right-hand corner and say entire screen.
Yes, I've done it. I started everything from the beginning. Don't worry.
Okay.
Now I'm in business.
But I don't. Oh, yes, you're right. You are right.
Yes. Unfortunately, my laptop slept for overnight. That's why it forgot where is my file. I'm sorry.
Okay.
I'm joking.
Okay. Well, all's well that ends well. So I'm going to remove myself, which will mean as soon as I do that, I'll be silent, and you'll be the sole occupier of the floor. But in a moment or two, I'll delete your photograph so that the screen is maximized, but you'll still have audio. Okay. And if you need me, just call me.
Okay. So, thank you so much.
Thank you very much. The
floor is yours. To start my new presentation.
It's all yours now, Vladimir.
Thank you very much. Hello, everyone. Thank you for coming. Let's continue my next presentation. Dark matter concept. Considering your comments in the previous presentation and the private communication with Harry Ricker, I researched the concept of dark matter and came to the point that this concept is not exactly what I mean about new kind of matter in frames of world universe model. In whom dark matter is not dark at all. It was dark 240 years ago when Mitchell proposed dark stars and astronomers had only telescopes. They observed the sky with their eyes only. For them, dark stars were dark. The first known binary system was Cygnus X1, that is typically the brightest persistent source of hard X-rays with energies up to 60 kiloelectron volts. In 2000, Minchin et al. Discovered binary galaxy system Virgo HI21 with NGC 4254, which has the 21 centimeter emission. They are not dark because the contemporary astronomy allows us to observe the sky in wavelengths from radio waves up to gamma rays. In my previous presentations, I followed the standard paradigm dark matter that is not quite right for womb, in which the world consists of particles of ordinary matter, protons, electrons, photons, and neutrinos. On the other hand, there are particles created by the universe, universe created particles of a new kind of universe created matter, which have following characteristics: fermions or bosons, rest energies covering 18 orders of magnitude, weak interaction, and self-annihilation like Majorana fermions. Ordinary particles are a byproduct of UC particles self-annihilation. It is easy to switch from dark D matter to universe-created UC matter. In whom the nucleus of the world 4D ball is expanding in the fourth spatial dimension with speed c, gravitodynamic constant, and the world 3D hypersphere is stretching. The eternal universe is the creator of UC matter in 4D nucleus. UC particles carry new UC matter into the world. It is important to emphasize that continuous creation of matter is a direct consequence of the nucleus expansion. Creation of UC matter occurs homogeneously in all points of hypersphere world. Worm is not like the old steady-state theory, in which the density of matter in the expanding universe remains unchanged due to a continuous creation of matter. In whom the density of matter is going down inversely proportional to cosmological time. The world consists of medium and macro objects. Medium is some kind of ether made of ordinary particles and UC particles with very low density, about 10 to the minus 26 kilogram per cubic meter in present epoch. Total density of the world equals to a critical energy density throughout the world's evolution. It provides a flatness of the world. The energy density of medium is 2/3 of the total energy density, and macro objects, superclusters, galaxies, extrasolar system, 1/3 in all cosmological times. Relative energy density of UC particles is about 92.8%, and ordinary particles about 4.8% in the medium and 2.4% in macro objects. I stress that the content of all particles is the same in the medium and macro objects. But in the medium, the density of them is the same. The medium is homogeneous. And in macro objects, there are cores made of UC fermions and shells of all other particles around them, like hills. Introduction. According to Wikipedia, solar system is gravitationally bound system of the sun and the objects that orbit it. It formed 4.57 billion years ago. The vast majority of solar system mass is in the sun, with most of the remaining mass contained in Jupiter. The four inner system planets, Mercury, Venus, Earth, and Mars, are terrestrial planets. The four giant planets of the outer system, Jupiter, Saturn, Uranus, and Neptune, are substantially larger than the terrestrials. All 8 planets have nearly circular orbits that lie near the plane of Earth's orbit, called the ecliptic. There are unknown number of smaller dwarf planets and innumerable small solar system bodies orbiting the sun. 6 largest possible dwarf planets and many of the smaller bodies are orbited by natural satellites commonly called moons after Earth's moon. Asteroid belt, which lies between the orbits of Mars and Jupiter, contains objects composed of rock, metal, and ice. About 60% of the main belt mass is contained in the four largest asteroids, Ceres, Vesta, Pallas, and Hygiea. The total mass of the asteroid belt is about 3% that of the Moon. Beyond Neptune's orbit lie the Kuiper belt, that is a circumstellar disk in the outer solar system, extending from the orbit of Neptune at 30 astronomical units to approximately 50 astronomical units from the Sun. Most Kuiper belt objects are composed largely of frozen volatiles such as methane, ammonia, and water. The Kuiper belt is home to most of the objects that astronomers generally accept as dwarf planets: Makemake, Orcus, Pluto, Haumea, Quaoar. The total mass of Kuiper belt is about 1/100 of Earth's mass. Trans-Neptunian objects are any minor planets in the solar system that orbits the Sun at a greater average distance than Neptune. The first discovered in 1930 was Pluto. The most massive known is Eris, followed by Pluto, Haumea, Makemake, and Gong. More than 80 satellites have been discovered in orbit of trans-Neptunian objects. 12 minor planets with a semi-major axis greater than 150 astronomical units and perihelion greater than 30 astronomical units are known, which are called extreme trans-Neptunian objects. Oort cloud is a theoretical concept of a cloud of predominantly icy planetesimals proposed to surround the Sun at distances ranging from 1,000 to 100,000 astronomical units. It is divided in two regions: a disk-shaped inner Oort cloud and spherical outer Oort cloud. Both regions lie beyond heliosphere and are in interstellar space. The inner cloud is a vast theoretical circumstellar disk whose outer border would be located at around 20,000 astronomical units from the Sun. The outer edge of the outer cloud might be about 100,000 astronomical units from the Sun. Its total mass is not known, but roughly the combined mass is 5 times that of Earth. No known estimates of the mass of the inner Oort cloud have been published. Astronomers conjecture that the matter composing the Oort cloud formed closer to the Sun and was scattered far into space by the gravitational effects of giant planets early in solar system evolution. There are two main classes of comets: short period comets, called ecliptic comets, and long period comets, called nearly isotropic comets. Ecliptic comets have relatively small orbits below 10 astronomical units and follow the ecliptic plane, the same plane in which the planets lie. All long period comets have very large orbits, thousands of astronomical units, and appear from every direction in the sky. Facts about planets and moons. According to Evolution Encyclopedia, there are the following facts that do not fit into any evolutionary theory of how our solar system came into existence. A full 99.5% of all angular momentum in the solar system is concentrated in the planets, yet a staggering 99.8% of all mass in our solar system is located in our Sun. Jupiter itself had 60% of the planetary angular motion. This strange distribution was the primary cause of the downfall of the nebular hypothesis. 290 years old and nothing new. Both Uranus and Venus rotate backwards to that of all the other planets. Why then does Venus rotate slowly backwards and Uranus rotate at a 98-degree angle from its orbital plane? 1/3 of 60 moons in our solar system have retrograde backward orbits, which are the opposite of the rotational direction of their respective planets. There are such striking differences between planets and planets, planets and moons, moons and moons. If they all came from the same gas clouds, they should all be alike. Solar system and moon. Let us consider rotational and orbital angular momentum of all gravitationally rounded objects in solar system from Mimas, a small moon of Saturn with mass about 10 to the power 19 kilogram, to the Sun itself. We calculate their angular momentum in the present epoch. See Table 1. Table 1, value of rotational and orbital angular momentum of gravitational round objects in solar system. These are the planets, these are the moons, this is their rotational angular momentum, this is orbital momentum. Nobody done this table before myself. From the point of view of rotational fission model, the prime object is transferring some of its rotational momentum to orbital momentum of the satellite. It follows that rotational momentum of the prime object should exceed the orbital momentum of the satellite. From table 1, we see that the orbital momenta of most satellites are indeed substantially smaller than the rotational momenta of their prime objects, with 3 exceptions. The rotational momentum of the Sun is smaller than Jupiter, Saturn's, Uranus, and Neptune's orbital momentum. The rotational momentum of the Earth is substantially smaller than Moon's orbital momentum. The rotational momentum of Pluto is considerably smaller than Charon's orbital momentum. Considering that Jupiter's orbital momentum is about 60% of the total angular momentum of solar system, we obtain this value for the total rotational angular momentum of solar system. Let's calculate parameters of the overspinning speed at equator exceeding escape velocity, Sun's core, necessary to provide this angular momentum. Considering mass of Sun 2 multiplied 10 to the power 30 kilograms, radius about 0.7 million kilometers, we obtain this value, which is 3.3 times greater than the total rotational angular momentum. It follows that the Sun's core can be smaller. Let us consider the structure of the Sun. According to the standard solar model, it has core that extends from the center to about 20-25% of the solar radius, contains 34% of the Sun's mass, with density rho maximum 150 and rho minimum 20,000 kilogram per cubic meter. It produces all Sun's energy. Radiative zone from the core to about 70% of the solar radius, with density rho maximum 20 and rho minimum 0.2 thousandths kilogram per cubic meter, in which convection does not occur and energy transfer occurs by radiation. Core and radiative zone contain practically all Sun's mass. In our opinion, the Sun has an inner core, nucleus, made up of UCF1 with rest energy 1.3 teraelectron volts, whose radius is 20-25% of the solar radius, and an outer core made up of UCM, the relative zone, the radiative zone. We then calculate the overspinning solar core rotational angular momentum before rotational fission and found that it is 2.8 times larger than overall angular momentum of solar system. The large power output of the sun is mainly due to the huge size and density of its core compared to the Earth, with only a fairly small amount of power being generated per cubic meter. Theoretical models of the sun's interior indicate a maximum power density of approximately 276.5 watts per cubic meter at the center of the core, which is about the same power density inside of a compost pile and closer approximates reptile metabolism than a thermonuclear bomb. Let's follow the same procedure for Earth-Moon pair. Considering the mass of Earth and radius, we calculate rotational angular momentum of Earth that is 2.3 times larger than the Moon's orbital momentum. Let us look at the structure of the Earth. According to standard model, it has an inner core, an outer core that extend from the center to about 45% of the Earth's radius, with density Rho maximum 13 and Rho minimum 9.9 thousand kilogram per cubic meter. Lower mantle spanning from the outer core to about 90% of the Earth's radius, below 660 kilometers, with density Rho maximum 5.6 and Rho minimum 4.4 thousand kilogram per cubic meter. Inner core, outer core, and lower mantle contain practically all of the Earth's mass. Very little is known about the lower mantle apart from that it appears to be relatively seismically homogeneous. Outer core, lower mantle boundary has sharp drop of density. It's very important, from 9.9 to 5.6 thousand kilogram per cubic meter. In our opinion, lower mantle is part of the Earth's core. It could be significantly different 4.57 billion years ago, since during this time it was gradually filled with all chemical elements produced by Earth's core due to UCF1 1.3 tera-electron volt self-annihilation. Considering the Earth's core with radius 5.7 thousand kilometers, the rotational angular momentum equals to this value, which is 2.2 times larger than the orbital momentum of the Moon. As for the Pluto-Charon pair, it is definitely a binary system. Charon was not generated by Pluto's core. Instead, they are two objects that happened to be bounded together by gravity. Mysteries of Solar System. According to Ellen Stone, editor-in-chief at Little Astronomy, these mysteries are: why does Venus spin backwards? All the planets in solar system rotate in the same direction except one, Venus. If you could look at all the planets from a point at the top of the North Pole, you would see all of them rotating counterclockwise, but not Venus, that is spinning clockwise. Astronomers have two theories to explain why that happens. One of them is Venus could have suffered a huge impact with another object. That collision would have been so powerful it changed the direction of Venus' rotational movement. The second theory is Venus is so close to the Sun and its atmosphere is so dense that gravitational pull from the Sun created tides that flipped the planet's axis 180 degrees. Can you believe it? Why is Uranus tilted sideways? Something very curious happens with Uranus rotation. It seems like the planet is on its side if you compare it to the other planets in the solar system, while the rotational axis of the other planets is mostly perpendicular to the directions of the sun. Uranus' axis is tilted and almost pointing to the star, making the planet look like it is rotating on its side. It is possible at some point in its history, a huge object impacted Uranus and changed the direction of its axis. Some theories suggest that very same impact created most of all of its 27 moons. Unbelievable. Boom. In our view, explanations of system mysteries, Venus spinning backwards, Uranus tilted sideways, moon creation, Mars hit by a giant cosmic lightning bolt, planets difference in composition based on the impact theory are unrealistic and were proposed from hopelessness in frames of standard model. To the best of our knowledge, in literature, it was never discussed and explained a real picture of planets' angular momentum. We will see it on figure 1 and table 2. Why do the sun and all planets have different orientations of their motion being created from the same nebula with a certain amount of angular momentum? Where it came from, nobody knows. Figure 1, orientation of the motion of solar system objects. Let me put attention to the North Galactic Pole. The North Galactic Pole, look, the direction of this and that, and North Galactic Pole, celestial pole. Why they're so much different? Why angle of galactic much different from solar and Earth pole? Table 2, angular momentum of gravitational rounded objects of solar system. There are two parameters, inclination in degrees, and you can see the variation of inclination from planet to planet, and axial tilt. That is huge difference from 0 to about 98%. In astronomy, axial tilt in the angle between an object's rotational axis and its orbital axis, which is the perpendicular to its orbital plane. Equivalently, it is the angle between its equatorial plane and orbital plane. It differs from the orbital inclination. That is the tilt of an object's orbit around a celestial body. It is expressed as the angle between a reference plane and the orbital plane of axis or direction of the beginning of orbiting object. The ecliptic plane is the orbital plane on Earth of Earth around the Sun. The galactic plane is the plane on which the majority of a disk-shaped galaxy mass lies. The directions perpendicular to the galactic plane point to the galactic poles. With the law of conservation of angular momentum, we developed our model in which big angle between galactic pole and ecliptic pole is due to the random volcanic rotational fission of Milky Way UCMM core of many extrasolar systems UCM cores at the same time. So the direction of the sum of all extrasolar systems' angular momentum coincide with the direction of galactic poles. The same explanation is valid for the sun's UCM core and USM core for the planets with moons, considering that they were created at the same time 4.57 billion years ago. Why is the sun's atmosphere hotter than its surface? One of the bigger and most counterintuitive mysteries of the solar system, for which we have not been able to find answers, is why is the outer layer of the sun's atmosphere hotter than the surface of the star? The sun is composed of multiple layers. The visible source of the surface of the part we can see is called the photosphere and burns at a temperature of about 5700 K. On top of that, the sun also has an atmosphere, and the outermost part of it is called the corona. One would think that being separated from the surface, the heat would start to dissipate, and the temperature of the coronal would be lower than on the surface. Well, this is not the case. In fact, it is the extreme opposite, as the temperature in the corona can reach million degrees K. Some theories have been formed as to why this happens, that have to do with the ionization of helium in the atmosphere, but we don't know for sure. In boom, solar corona is an aura of plasma that surrounds the sun and extends at least 8 million kilometers into outer space. Sun's radius is 0.7 million kilometers. Spectroscopy measurements indicate strong ionization and plasma temperature over a million degrees K. Corona emits radiation mainly in X-rays, observable only from outer space. Plasma is transparent to its own radiation and to solar radiation passing through it. Coronal heating problem in solar physics relates to the question of why the temperature of the solar corona is millions of degrees higher than that of the photosphere. The high temperatures require energy to be carried from the solar interior to the corona by a non-thermal process. In our opinion, the origin of the solar corona plasma is not coronal heating. Plasma particles, electrons, protons, multi-charge ions, are so far apart that plasma temperature, in the usual sense, is not very meaningful. Plasma particles are the result of self-annihilation of UC particles, in whom solar corona made up of UC particles resembles a honeycomb filled with plasma particles. Geocorona and planetary coronas possess features like those of solar corona. The following experimental results speak in favor of this model. Corona emits radiation mainly in X-rays due to self-annihilation of UC fermions UCF3 with 3.7 kiloelectron volts rest energy. The elemental composition of the solar corona and the solar photosphere are known to differ. During the impulsive stage of solar flares, hot X-rays and gamma rays with energy about 100 gigaelectron volts are emitted. One gamma quant had an energy as high as 467.7 gigaelectron volts. In our view, it is the result of enormous density fluctuations of particles UCF1, 1.3 teraelectron volts in the solar corona and their self-annihilation. These fluctuations, named coronal mass ejections, originate from the random volcanic activity of the sun's UCM core. Most powerful solar flares have coronal mass ejections. How many unknown dwarf planets are out there? Our telescopes have been getting better really fast in the last few decades. With all these advancements, we started to find a lot of objects in solar system we didn't know about. This led to the creation of the dwarf planet category to label all these objects that did not really meet the criteria to be called a planet but were pretty close. The International Astronomical Union has officially recognized five dwarf planets so far, including Pluto, but there are at least 30 other objects that have been proposed by multiple astronomers that they will be studied further in the coming years to see if they meet the criteria. Most of these dwarf planets would be located in the area known as the Kuiper belt, beyond the orbit of Neptune. Some astronomers believe there might be up to 200 dwarf planets out there waiting to be found. In my model, from physical point of view, all gravitationally rounded objects in solar system, from Mimas, a small moon of Saturn, to the Sun, are macro objects with UCM cores inside of them that are USM reactors. It includes stars, planets, dwarf planets, and moons that are bigger than Mimas. Considering the total mass of the Kuiper belt, about 1/100th of Earth's mass, we can evaluate a number of macro objects. It's about 10 to the power 3, about 1,000. So there might be up to 200 dwarf planets in the Kuiper belt as it was hypothesized. Does the Oort cloud exist? Have you ever wondered where do comets come from? To solve that question, astronomers have theorized that a group of millions and maybe billions of small icy rocky objects exist on the outer limits of the solar system. These objects form a huge cloud named the Oort cloud after one of the astronomers who proposed it. Sometimes these objects will change, be shot out of the Oort cloud due to the collisions of gravitational forces and become wandering comets. The objects in the Oort cloud are too small and far away to reflect any light from the sun, so their existence is still not confirmed. Boom. In our opinion, observations of short period ecliptic comets and long period isotropic comets are experimental confirmation of the Oort cloud existence, in whom ecliptic comets were produced by the sun itself as the result of volcanic rotational fission of the sun's UCM core. Nearly isotropic comets were produced by giant planets, which are in fact failed stars with different directions of rotational axis as the result of volcanic rotational fission of their UCM cores. Take a look at table 1. Oort cloud belongs to solar system. How was the moon created? One of the things that says a lot about how little we still know about our universe is the fact we don't even know for sure how our own moon was formed. The current theory most astronomers agree on is that at some point early in the solar system's life, a planet around the size of Mars crashed against Earth. This collision left a lot of debris and pieces of both planets hanging around but still trapped by Earth's gravity and were left orbiting it. After millions of years, all these pieces came together thanks to gravity and formed the moon. While the theory is widely accepted, it leaves some questions up in the air, like why was not Earth taken out of its orbit by this impact? And what happened to the other hypothetical planet? In whom the moon is a differentiated body being composed of geochemically distinct crust, mantle, and planetary core. Moonquakes have been found to occur deep within the mantle of the moon, about 1,000 kilometers below the surface. The size of the lunar core is only about 20% size of the moon itself, is in contrast to about 50% as is the case for most other terrestrial bodies. In February 2022, astronomers used NASA's Sophia telescope to scan an immense region near the south pole of the moon and revealed an abundance of water trapped on the shady sides of mountains and in the shadowed parts of craters. In whom the internal structure of the moon can be explained the same way as it was done for the Earth and Mars. It is worth noting that UCM core of the moon is much less than UCM core of the Earth. This result is in good agreement with the proposed by whom mechanism of the moon creation. UCM core of the moon was born as the result of volcanic rotational fission of the Earth's UCM core 4.57 billion years ago. Did Mars have oceans in the past? For years, astronomers have found evidence of erosion, channels, and canyons on Mars. As far as we know, all of those are caused by liquid water slowly forming them. From that data, we can hypothesize that at some point in the past, Mars has liquid water running on the planet. Some astronomers think even one-third of the Martian surface could have been covered in water. Some scientists believe even today it would be possible for water to exist under Mars' surface, where it is safe from many of the effects that would have caused the surface to disappear. The more we explore and study Mars, the more this theory seems correct, but that opens other questions. What happened to Mars that made all that water evaporate or freeze? Could there have been life on the red planet at some point? Boom. The proposed concept of UCM reactors in cause of all gravitational rounded marker objects successfully explains all contemporary hypotheses and results for the early Earth. In the paper Uncovering Mysteries of Earth's Primeval Atmosphere 4.5 billion years ago and the Emergence of Life, a leading scientist Saucy wrote, 4.5 billion years ago, Earth would have been hard to recognize. Instead of the forests, mountains, and oceans that we know today, the surface of our planet was covered entirely by magma, the molten rocky material that emerges when volcanoes erupt. This much the scientific community agrees on. What is less clear is what the atmosphere at the time was like. In whom upper mantle with crust are due to the UCM core volcanic activity of the homemade compositions, including magma, which produced as the result of the self-annihilation of UC particles in the UCM core. It explains the result that continental crust had formed by 4.5 billion years ago. According to Learning Earth Science, scientists have developed a number of hypotheses about how the oceans formed. Though these hypotheses have changed over time, one idea now has the wide support of Earth scientists, called the volcanic outgassing theory. This means that water vapor given off by volcanoes erupting over millions or billions of years cooled and condensed to form Earth's oceans. In whom Earth's atmosphere and oceans were formed by the volcanic activity and outgassing of USM core. In our opinion, analogous processes happened on early Mars too. But because of much less size of USM core and mass of Mars, in comparison with the Earth, the rate of creation of Mars atmosphere and oceans, and the forces of gravity preventing the water from leaving the planet are much less than it is for the Earth. So, water evaporated from the surface of Mars. We believe that there is an underground water on Mars. Was Mars hit by a giant cosmic lightning bolt? There is a huge, strange canyon on Mars called Valles Marineris. Just to give you an idea of how big it is about 4 times deeper and 5 times longer than the Grand Canyon in Arizona. But its weirdness only starts there. Some scientists believe this canyon was not formed in a traditional way, water slowly eroding the land over the course of millions of years, but in a much cooler manner. They believe Valles Marineris is a scar. For years, scientists have theorized the existence of cosmic lightning bolts. Imagine a lightning bolt, but on a cosmic scale, traveling across the cosmos with unimaginable amounts of energy. Then imagine this bolt hits a planet, let's say Mars. The impact would be big enough to leave a mark forever on the planet and create a valley the size of Valles Marineris. One more piece of evidence that could support the lightning bolt theory is that Mars also has a hole in its atmosphere that is leaking hydrogen into space. Could this hole have been created by that very same impact? Is that the reason Mars lost its ocean? Boom! In our view, a giant cosmic lightning bolt and Valles Marineris is a scar on the Mars surface are unimaginable. Some of the most notable surface features on Mars include Olympus Mons, the largest volcano and highest known mountain in solar system, and Valles Marineris, one of the largest canyons in solar system. Mars is seismically active. In 2019, it was reported that InSight had detected and recorded over 450 Marsquakes and related events. In 2021, it was reported that the core of Mars was indeed liquid and had a radius of about 1830 kilometers and a temperature around 2000 degrees K. In whom the Martian core is a liquid UCM core with very high viscosity that functions as a solid-state object. It is a UCM reactor that provides enough energy for volcanic and plate tectonic activities. As the result, there were created Olympus Mons and Valles Marineris. Why are the planets so different in composition? Most astronomers agree on the origin of solar system. They believed a disk of rocks and pebbles formed around the sun, and they started fusing, impacting one another, and fusing together to form the planets. But this creates a problem. If all the planets formed from the same disk and grew together at the same time, how come they ended up being so different from one another? Some of the differences between planets can be attributed to variables like how close they are to the Sun. This explains, for example, why some planets could hold liquid water like Earth and maybe Mars, while others cannot because they are too cold. But it doesn't explain other things like the vast differences in size and composition. Some theories suggest solar winds blew away the lighter materials, allowing for the outer planets to have a different composition. Another study found a correlation between the calcium isotope and the size of the planets, suggesting planets grew at the same rate but then stopped growing at different times. How come? Boom. According to the developed model of macro objects, all chemical elements, compositions, rocks are produced by macro objects themselves as the result of UC particle self-annihilation. The diversity of all gravitationally rounded objects of solar system explained by their distance from the sun and the differences in their UCM cause mass, size, composition. UCM reactors inside of them in hydrostatic equilibrium provide sufficient energy for all geological processes on planets and satellites. Do Jupiter and Saturn even have a core? When we have lived only on one planet, it is hard to imagine how a different one might be so different and weird, and in the case of Jupiter, Saturn, and others, so not solid. While these two gems of our solar system look just like a planet, they are mostly just gas as far as we can tell. If you were to take a guess without knowing, it would be easy to think behind all those storms, clouds, and gas we see on top of those planets, there would be a surface we might be able to land on someday and explore. Well, there is not. If you were to drop something on Jupiter, it wouldn't hit the surface. It would just drop down into the center of the planet until it was crushed by the pressure. Scientists believe both planets might have a core with a thin, rocky, or icy layer in the middle because it fits with our current model of how planets are formed. The problem is we have never actually seen or confirmed such core exist, and data found by the Juno spacecraft on Jupiter left us with more questions than answers, as it suggests Jupiter's core might be dissolved. In whom all planets, including Jupiter and Saturn, have UC matter cores. Why does Pluto have mountains? The dwarf planet Pluto has some of the most unique features of any other object in solar system. It has huge mountains made among almost entirely out of ice. The question that puzzles scientists is where did they come from? For a mountain to be created, there needs to be geological activity. That means tectonic plates moving because of volcanic activity or some other form of heat release. And that's where the big mystery lies. Where are the heat and energy coming from? As far as we can tell, Pluto is too far away from the Sun to receive much energy from it, and its core is just ice and rocks, so there is no lava flowing. One theory suggests Pluto might have some sort of system of cryovolcanoes, which are basically volcanoes that spit water or gases. But there really still remains a question to be answered. Reality still remains a question to be answered. Whom Pluto have mountains due to the volcanic activity of USM reactor inside of it. How big is the solar system really? As we mentioned above, when we talked about the Oort cloud, we still don't know much about the outer edges of solar system. So much we don't even know where it ends. Some astronomers mark the end of solar system at the heliopause, the imaginary line where the solar winds stop. That would make solar system about 79 astronomical units wide in diameter. But the Oort cloud would be located way beyond that. If we take the Oort cloud as the line for the solar system end, it is estimated it could be up to 200,000 astronomical units away, or a little more than 3 light years. Whom, according to whom, the radius of solar system is about 96,000 astronomical units. That is in a good agreement with the size of the spherical outer Oort cloud, 100,000 astronomical units. It was created as a result of volcanic rotational fission of the overspinning UCM cores of giant planets Jupiter, Saturn, Uranus, and Neptune, which are in fact failed stars and have significantly different inclinations and axial tilts. All long-period nearly isotropic comets have very large orbits and appear from every direction in the sky. Helene Stone made the following conclusion. As you can tell from our list, there are still many questions about our solar system that need to be answered. We only picked the most interesting ones for this list, but there are many more that did make the cut, like the crater shaped like a spider in Mercury, or why is Titan the only moon with an atmosphere? With all the advances in equipment and new techniques, we will hopefully get some answers to a lot of these questions in the coming decades, so to stay tuned and keep learning. Maybe you will be the one who figures them out. I'm absolutely agree with Ellen. We have not so much know about our own solar system we live in. Explain problems of solar system. Whom solves a number of physical problems in contemporary cosmology and astrophysics through UC particles and their interactions. Coronal heating problem relates to a question of why the temperature of the solar corona is millions of degrees higher than that of the photosphere. According to whom, the origin of the solar corona plasma particle is not coronal heating. Plasma particles, electrons, protons, multi-charged ions are so far apart that plasma temperature in the usual sense is not very meaningful. Plasma is the result of the self-annihilation of UC particles. The solar corona, made up of UC particles, resembles a honeycomb filled with plasma. Cores of Sun and Earth rotate faster than their surfaces, despite high viscosity of the internal medium. Whom explains the phenomenon through absorption of UC particles by cores. UC particles supply not only additional mass proportional to tau in power 1.5, but also additional angular momentum proportional to tau squared. Cores irradiate products of self-annihilation which carry away excessive angular momentum. Solar wind is the result of this mechanism. Internal heating of gravitationally rounded objects in solar system is explained by UCM reactors inside of all macro objects, fueled by UC particles. Internal heating is due to UC particle self-annihilation. Diversity of gravitationally rounded objects in solar system is explained by UC reactors inside of macro objects fueled by UC particles. All chemical elements, compositions, radiations are produced by macro objects themselves as the result of UC particles self-annihilation in their different UCM cores. Plutonium-244, with half-life of 80 million years, exists in nature. It is not produced by the nuclear fuel cycle because it needs very high neutron flux environments. Any Pluto-244 present in the Earth's crust should have decayed by now. In whom all chemical products of the Earth, including isotopes, are produced within the Earth as the result of USF1 self-annihilation. They arrive in the crust of the Earth due to the convection currents in the mantle carrying heat and isotopes from the interior to the planet's surface. Explaining Earth. Hypothesis asserts that the position and relative movement of continents is at least partially due to the volume of Earth increasing, in whom the Earth's USM core absorbs new UC particles and its size is increasing in time proportional to root square of tau. Hence, there is an expansion of UCM core and its surface, the upper mantle with crust, is likewise expanding. Due to UC particle self-annihilation, new chemical elements are created inside of the upper mantle with crust. As the result, the relative movement of continents is happening. Faint young sun paradox describes the apparent contradiction between observations of liquid water early in Earth's history and the astrophysical expectation that the sun's output would be only 70% as intense during that epoch as it is during the modern epoch, in whom all macro objects of the world were fainter in the past. As their cores absorb new UC particles, the sizes of macro objects and thus their luminosity are increasing in time proportional to tau. Considering the age of the world, 14.2 billion years, and age of solar system, about 4.7 billion years, it is easy to find that a young sun's output was only 67.6% or what is today. Solar corona, geocorona, and planetary coronas made up of UC particles resemble honeycombs filled with plasma particles, electrons, protons, multi-charge ions, which are the result of UC particles self-annihilation. Conclusion. The world consists of two different kinds of matter, UCMM, 92.8%, with self-annihilating UC particles, and ordinary matter, 7.2%, that is in fact electromagnetic matter with particles, protons, electrons, photons, and neutrinos. They have different origin of radiations. Electromagnetic waves from radio waves up to X-rays are emitted by electrons outside nuclei. Gamma rays are emitted by nuclei, as it is the case for self-annihilating UC particles. Majorana fermions, long theorized particles that are their own antiparticles, were hypotized by Ettore Majorana In 1937, scientists have yet to detect these self-annihilating particles inside particle accelerators. In our opinion, proposed by whom you see particles confirm this prediction. It is worth noting that in the same year, Paul Dirac foresaw the future of physics in a new cosmology. Considering GWST discoveries, successes of whom, and 86 years of Dirac's proposals, it is high time to make a paradigm shift for cosmology and classical physics. Astronomers have got achievements in investigations of the solar system that became an experimental laboratory for astrophysicists to check their theories. We are at the beginning of the new era of astronomy, cosmology, and astrophysics. Young physicists should be a part of it. They should concentrate their efforts on the development of a new cosmology and classical physics. I am very excited about the future of physics. Acknowledgements. I am always grateful to academician Prokhorov and Manenkov, whose influence on my scientific life has been decisive. I am eternally grateful to my scientific father, Paul Dirac, who was a genius and foresaw the future of physics in a new cosmology. I am forever grateful to Nikola Tesla, who was a genius. I am much obliged to Professor Korda for publishing my manuscripts in Journal of High Energy Physics, Gravitation, and Cosmology. I am grateful to Nick Percival and Harry Ricker for valuable comments and suggestions which have led to an overall improvement of the presentation. Special thanks to my son Ilya, who helped me clarify model and improve its understanding. This is the end of my presentation. Thank you very much for your attention. I am ready for your questions.
Well, once again, many thanks, Vladimir. We sometimes think we've heard it all, but then you give a new complexion, and we're equally intrigued. Now, let me see, can I just remove this for the moment? That's better. And in fact, you know, there is a lot of discussion going on here. I think Quest said, you've obviously been doing very diligent work, which we must acknowledge over many years. That's quite obvious. So, actually, maybe just before briefly going through the questions, and I think there'll be more comments today, so we might have a bit more time for discussion, although we have absorbed a bit of extra time, but that's fine. I said, you know, 1:15 would be fine. Just maybe one quick question, which is maybe fundamental, and I hope I haven't missed anything. But basically, I think you said, Vladimir, that the evolution is that the density of the universe is decreasing in time. So if that's so, let me just get this clear, because you envisage a sort of an initiation of your type of dark matter for a period, and then you have the ordinary matter which comes in. So what is the evolution? Is it a system from the beginning, if you like, where the density is increasing, and then after a period of time it just starts to decrease, and then ultimately there'll be just nothingness, just a plain, you know, equal density, very low density in the universe? I just didn't understand that.
You know, first of all, the composition of the medium, macro objects, all time the same. The ratio of different components, different particles are the same. No difference the whole life. It doesn't mean that we created not dark matter. Let me name now new name of these particles. Universe created matter. That's its a point. Universe created particles. It's exactly what is my model about. It is not dark. They were dark on these particles when we had only telescopes. Now we have all the advantages of our contemporary astronomy that we can see everything from gamma quants to 21 centimeters. That is the first part of the question. The second part is why our medium, and macro objects going down with the density, because we have all the matter, all the particles coming outside, and it's the quantity, the number of additional matter, additional particles is proportional to the sphere, to the surface sphere. And when you will divide the surface sphere with constant sigma zero, it's an energy density at the surface, on a volume of any object, it will be exactly the ratio inversely proportional to radius and to time of the macro object existence. That's why it's no uniqueness. It's only payment for the creation of these, all the particles from outside. As, by the way, I'm sorry. I'm so sorry. I'm a little bit tired. That's why let me have a little break. Like, it was proposed by genius Nikola Tesla. He told that all the matter, all the energy we have inside of any object are from outside. It's exactly realization of his main idea. All matter what we have around, it is outside. And the most important is from outside, from the universe, the main creator of UC matter.
So, you said, I think earlier, that in contradistinction to the steady state model, and the models maybe with continuous creation, you were envisaging your own system. So maybe how would you envisage the universe to be in millions and millions and millions and 10 to the whatever years in the future? Would it be very different from what it is now?
It will be different, because all the time, continuously, we have new matter. All the macro objects, what we have right now, they will grow up. No doubt they will grow up, no doubts about it. It will be composed new macro objects, new superclusters, new galaxies, new planets, and all this stuff. Nothing will happen to them. It will be extra macro objects in the universe. That, taking into account, considering that universe is eternal and they have infinite creation activity, then all our world will develop with bigger radius in time without any problem. Because we have extra matter, and it's enough to create new macro objects. As for the temperature of microwave background radiation, it will be going down infinitely to zero. That's why.
Okay.
You see what is important? The temperature of microwave background radiation will go down, but it doesn't mean that macro objects will stop to increase. No, I developed the model with a cold creation of macro objects. It does matter what is the temperature of microwave background radiation and the medium of the world. The most important, what is the angular momentum of the main object, that it will have a volcanic activity, and it will extract new planets, new moons, new galaxies, and all this stuff. That's why the future of the world is positive. Nothing will happen to it. It will be more and more galaxies and stars. Even in our galaxy, every year we have a few new stars. How come? Where they came from? Where the matter for them? That's why. And there are so active galaxies. There are some galaxies with thousands of new stars, new galaxies created every year. That's why now it will develop only with the more and more macro objects, macro structures in the world.
Well, I think it's been very, very interesting applying this sort of very fundamental theoretical basis to practical objects, in our vicinity. And I can see that a lot of questions are coming in. They're talking about colonizing Mars and, the different types of planets and so on. So it's obviously given rise to a lot of discussion. But here's one question from John Hodge. Is Planet 9 a planet or what? Dark matter? Any comment on that, Vladimir?
One more time, please. Sorry, I missed your question.
He's talking about Planet 9, this hypothesized Planet 9. Do you think it's a planet, or is there dark matter out there which...
First of all, let's forget about dark matter, because it was confusing people. There is no dark matter in my model.
Yeah, last time it confused people, probably.
Yes, it's confused. That's why I started my, thinking about what is going on, why dark matter is not accepted. And it was a very positive, my private communication with Harry. He asked me so good questions. What I wrote, my first page, was answering his questions. That's why I'm so happy about questions, because it's my initiation of a new thoughts, of a new approach, of a new explanations, what we have right now. That's why there is no dark matter.
So, by the way, are you using another term for the hypothesized matter that existed for the first, 0.4 thousand million years or something? You used to call it dark matter, but are you using
yes, I use it as a traditional dark matter, but always I told it's dark as you cannot see it with your eyes, but you can see it in gamma. Yeah, that's it. Simple like this, what I meant, what it was 240 years ago. Zwicky, he told dark matter, because in telescope you cannot see them. Even binary stars, they were saw and they were, observed only 188 years later. Why? Because you need your satellite, you need telescope and satellite. Only then you can see them. You see, simple like this. That's why I
similar to the ideas that I've put forward. That we're not seeing a one snapshot of any element of the distant universe. We're seeing a composite image, which is made up of light, which has actually reached us at that particular time.
Yes, it's exactly. Yeah, you're right. You're absolutely right. But what is important, I must go to contemporary astronomy, with all these radio waves up to gamma quants, John Mitchell, it was a great idea. He was absolutely right at his time. But it was 240 years ago. It's time to switch from dark matter to universe created matter. You see, it's very simple. Instead of 1D, to put UC, that's it, simple like this. That's why I tried even to rename my particles in the closest way that it will not be so much confusion for people, for scientists to read my papers.
Okay, well, I think that's generous of you actually as well, because if you had been using a term for some considerable time, which we were confusing with some other term, you very kindly agreed to rename that, so I hope it's helping you, but it's actually helping a lot of us. I can certainly...
Yes, it's exactly my point. But what are the planets? Let me tell you about the ninth planet.
Yeah.
You know what? There is some kind of, rules. What is a planet? What is a dwarf planet? And so on and so on. It's not physical. Physical is not, because if there is no on this orbit some other objects, it's a planet. If there are some objects, it's a dwarf planet or something else. It's wrong. Physically, all macro objects that have so named reactor inside of it can be named planets, because they are self-consistent. They have their absorption of energy, they can radiate energy, and they can exist for many, many years without any problems. That's why, if you want to know my opinion, even the definition, what is the planet, it's not physical. It is something, unnatural. Naturally, you should name all of them: dwarf planets, moons, Titan, our moon, all of them, they have the same nature inside. They have
It's
this
arbitrary.
yeah, that's why it will be much easier for me to tell, do you have your macro objects in Cooper belt or not? That's it. Macro objects with size and mass more than me mass, because me mass is the minimum size and mass that can support itself by itself. You see what I mean?
And you know that Brailovsky berated the philosopher Hegel for having accepted the ancient idea that there must only be 7 planets, because that was a perfect number, and he said, well, in Shakespeare's King Lear, the fool answers that, because he says to King Lear, the reason that there are only 7 planets is a pretty reason. So the king says, yes, because there are not 8. So the fool says, yes, you would make a good fool.
Thank you so much for this joke. But even Pluto right now, dwarf planet, it's absolutely wrong.
Yeah, I
It's
think
a
so as well.
binary planet, to Pluton and Charon. And that's it, simple like this. Binary system, binary planets. They're not dwarf. They have a very good size, much bigger than me Mars. It means for me exactly, it's a planet.
Yeah, it's an arbitrary definition, really, to take it out or put in. Okay. Did you deal with this from Quest? He says, why does Venus go in inverted commas clockwise while the other planets don't? Is that so?
If you will see from the North Pole on these planets, then you will see rotation clockwise and counterclockwise. No, it depends on our view from the pole.
If you view from the south, you get the opposite. But I think he's saying that if you view them all from the North Poles, this is anomalous. So, is there any particular reason for that? It's just maybe left and right. It could be one way or the other.
Matter. It doesn't matter. It doesn't matter how you will see. But what is important, all planets rotating in one way, and one of them rotating against this way. That's it. And how you will look at clockwise, it doesn't matter. It's only to make easy for people. They know what does it mean clock, and then it will be clockwise or counterclockwise. That's it. It's a simple explanation for normal people.
A tiny bit of conversation here. I'm not bothering you with it too much because it's not composed of questions, but about, say, the model of Tycho Brahe, where I suppose it's a geocentric theory, basically, that the planets go around the sun, but the sun goes around the Earth. But this man, Emin Pudama, I just said, well, I suppose you're talking about that theory. And he said, well, it's actually what he was talking about is similar to Tycho's model, but closer to that of a student, Longomontanus. So I'm not quite sure. I'd have to look that up, but you've no particular views on Tycho's model. It's really antiquated now, but a lot of these geocentrists, they adopt it nowadays because it would explain things like the anomalous retrograde motion of Mars, whereas the simple geocentric model wouldn't. But anyway, we just had a bit of conversation on that. I'm coming to the end of the questions because I'd like to get to the green room in a moment now. We're running a bit out of time. He's just talking about the sun's composition. Simon Schack is the man named in relation to this Tycho model and so on. But I think the conversation has really been sparked off by all that you've said. There are no very specific questions. I don't know. Maybe here's one. He says, the question of how the moon was created is similar to how all the planets were created. How old they giant chunks of rock eventually smooth out into almost perfect spheres. How did they?
Look, it's a little bit difficult for me to understand the question, but I don't know what to tell. Yes, moon was created as the result of volcanic activity of you see matter core of Earth overspinning, and that's it. Volcano activity we have always, but rotation with speed more than the speed desirable is only the way how you can split it out of your planet. You must have this speed enough, much more than you can extract your parts of volcanoes. We have volcanoes on our Earth. All these
Right.
stones going out of it, but they cannot leave the Earth because of the gravitation. That's why we need always spinning macro objects. Then, as a result of volcanic activity, you have enough speed to throw it away. Simple like this.
Okay. Well, I'll try to get through these comments to see if there are any more specific questions. Um, they're very interesting comments to read, but they're not something we need to absorb question time on. Well, I mean that's a general question. He said, did you or do you mention how the solar system started to exist? Well, you probably did. You covered that in talking about the 4.5 thousand million years ago. I maybe you didn't go into it in detail. I don't know. Um, I don't know. But,
There are so many details. I must cut all these details because I want to put in 1 hour as much as possible idea, phenomenon, how I
yeah.
explain them, and so on and so. I didn't use the mathematics what I developed for the confirmation of my conclusions. It's too much. As I told you, for
Yeah.
more than 10 years, I published hundreds of papers. That's why it's very difficult for me to find the right combination of ideas in one presentation.
Well, I think we're doing fairly well. I mean, we have 8 presentations, which seems like a lot, but you're covering all the aspects of all very lengthy research, from the macroscopic down to the Earth.
Yes,
And
next one
I
will be
dare say
Earth.
you could
I'm
devote
sorry.
8 sessions to the Earth. You could actually do that, but
Yes.
that's maybe for another day. Okay, well, thanks for that. Okay, a lot of more comments. Same question. The gentleman from Mexico, exchanging comments and so on. So I don't think there's anything that's coming there. Yeah, further. I think we can probably leave the questions now and get to the. Yeah, he's definitely interested to hear more and so on. Okay, now James Keane has presented about 4 points into the private chat. So rather than my trying to interpret them and just waste time as a middleman, I'll, with Jim's permission, I'll add him to the stage and let him make those points and anything else he wants to directly. So, Jim.
Okay, thanks again, Vladimir, for a very interesting presentation. May I note that your time unit presented in the previous presentation is within 2% of the hadron proton bit cycle time in binary mechanics. Now, this could be a coincidence or a rather amazing agreement between your work and approach to determine that time unit that you presented of 5.9 to the 10 to the minus 23 seconds. And this proton bit cycle in binary mechanics embodies angular momentum. So that I find that very interesting. In which, now here's a question, sir. In which presentations are the self-annihilation and volcanic rotational fission processes defined and explained at a level that might be understood by a particle physicist such as myself?
Okay. This okay. This is a question. Okay. self-annihilation and rotational fission as the model, as the main parts of my model, I introduced from the very beginning. From the very first my paper, I downloaded on, it doesn't matter, in 2013. That's why it is not something fresh. All my life, in all my papers, I used these definitions: self-annihilation and volcanic rotational fission. Self-annihilation I put only in words because I'm not expert in quantum physics. I don't know how it goes. I'm so happy to find Majorana hypothesis. He put it in 1937, close to 100 years ago. I hope that some quantum physicists like you will develop this mechanism, how it works. Because from classical point of view, for me, the most important is that as a result of this process, there are some gamma quants that are going out of this process. As it is, by the way, with electron positrons annihilation. But self-annihilation for me, it means instead of electron positive pair, you have electron and electron as an anti-particle annihilation. That's it. For me, I'm not expert in your business. That's why it's very difficult for me to tell. But the idea was developed the whole my life, and I'm happy that it was.
So it might be useful if those two aspects, which you two gentlemen would separately have, were sort of put together in some form.
Yes, you are right, but unfortunately, I'm not expert in quantum physics. There is nothing I can do in quantum physics.
Yeah, that's what I'm saying. Jim might be able to inject some
yes
idea.
And
into
if
that.
I initiate him to do some job in quantum physics, I will be happy. It's exactly my intention to initiate some curiosity of people, because I told you it's all my model is only basis for new physics. It's a basis. This is nothing developed. I'm not astrophysicist. I'm cosmologist. I'm not a particle expert like you. If you will try to develop Majorana fermions through the particles, antiparticle, you see particles, I will be more than happy. Believe me, I will glad to refer to your work and tell. By the way, it was developed by this scientist, and he found the way how it works. Simple like this.
So why does the moon ring like a bell when struck? Was that what were we
I
getting
don't
at there,
understand
Jim?
what does it
No,
mean.
this is Jim's point. I'm reading it here.
I
Yeah,
have no idea what does it mean.
Yeah, what does it mean, Jim?
Why does this is sort of maybe out of left field? Excuse me if that's the case, but it just occurred to me to ask you, why does the moon ring like a bell when struck?
I have no idea about his ring like bell. I'm so sorry. One more time,
Okay.
I'm not clear on the question either, to be honest.
Yes, I don't know. I'm very sorry.
Well, as if the moon were hollow to some extent, or a lower density within. At any rate, let me give time to others to ask questions and enter into the discussion. Thank you,
We had a
Vladimir.
very specific
Okay,
point.
thank you so
What is
much for good
matter outside?
questions.
Has that been answered? What is matter outside? Has he answered that, or are you clear, Jim?
Well, he mentioned matter outside, and I was just wondering what the definition of that was.
So would you like to address that just before we finish?
Okay,
Yes.
let me tell you a simple explanation. We have our sun, and we have corona outside with diameter 10 times more than the size of sun. That's why we have a macro object, we have a core inside, and we have all the shells around, including corona. Simple like this. That's why all the macro objects, they have all the same stuff, all the same particles. But core is core, what I give in some special tables. And all the shells around, it might be different distribution, different size, everything different. It's only to the way how to investigate them, how to observe them.
Okay.
Thank you, Vladimir.
By
there
the
was
way,
some point also,
let me
about
continue.
new Neptune objects, and that's past past Neptune. So thanks very much, Jim. Thanks for your contribution as ever.
Thank you.
Thank you. Now,
One short comment. Even planets, even our Earth, we have corona too. We have these particles, you see particles, outside of the Earth too. I will talk about these, effects in my next presentations. I cannot tell you everything. That's why have your patience for the next presentation. I will tell you about the structure of the Earth, and not only of the Earth, of the atmosphere of the Earth.
Okay. And I'll remind people of that just before we close today. So before I maybe twist anybody else's arm, because we're running out of time, we have a little time left. Is there anybody in the green room that would like to have a word? Okay. I think Denny just got in a second before Nick, so I'll bring Denny up there. Good day, Denny.
Thank you. Good day to you. I don't know if you know about it or not, but Martin Spears has developed a capacitance theory of gravity. But he died before he could finish up, so I wrote a book about it, trying to finish it up correctly. And that capacitance theory of gravity says that if we consider two particles that are not charged, then and that's all there is in empty space, then Newton's law would give the right answer. Newton's law, universal law of gravitation. But since it's a capacitance theory of gravity, if there are objects around with different dielectric constants than the empty space, then we have to take those dielectric constants into account as well to get the force between these same two particles, which are, as I say, are now, we're assuming that there are huge objects around, like the sun and Jupiter and so on, which would alter, they have, their dielectric constants are the same as empty space. And furthermore, as far as the photosphere and so on is concerned, a lot of those particles are ionized, and hence they have a positive or a negative charge. And as a result, and this Spears' capacitance theory of gravity gives a different result when treating these than it does in case of non-ionized objects, particles, if you like. And this brings me to my main point. Vladimir, I greatly admire your ingenuity and your persistence, but I can't help but think that before a really good theory of cosmology can be developed, the physics of particle physics, especially, and radiation theory and so on, has to be revised and to be more correct. You're using Newton's universal law of gravitation heavily, but if Spears is right, that's not a good idea, especially in regard to plasmas. I might mention that some people have heard of high hydrogen fusion, and they've developed things they call tomahawks or something like that to explain them. If you look on the website, it shows that President Gorbachev and President Reagan initiating this project, which is, of course, still going on because the money is still flowing. And but it's that old. It's like 30 years old, and they still haven't produced hydrogen fusion. And the reason seems to be is James Wesley has pointed out, the reason seems to be that they're using the wrong equations. Maxwell's equations are not good to use in a hot plasma, however useful they may be in other situations. And of course, they are useful in other situations. But so here again, you talk about hydrogen fusing in the sun, but the equations used to talk about that are Maxwell's equations, which aren't good in a plasma, which the interior of the sun seems to be a sort of a very dense plasma. So here again, it's hard to take the current theories in cosmology, including yours, as very meaningful, although extremely ingenious and interesting to listen to.
So that's a very specific point, perhaps, Vladimir. Maybe one should be applying different systems to plasma.
I'm sorry, what is the question? I'm very sorry. I was hearing very carefully, but what is your question? What do you want to ask me?
It wasn't really a question. It was just a remark that you're using obsolete physics, it seems, to as a basis of your cosmology.
So if I may butt in, my understanding of what maybe Denny is getting at, he was talking about Morton spheres and all that, but he's basically saying that if one uses maybe Maxwell's equations, well, they do apply and they work in ordinary life. But if you're looking at, say, the thing like the plasma of the sun, the corona of the sun, it's obsolete physics. You perhaps need to modify the equations. Is that maybe the germ of what you were getting at in the last part?
Yes. Yeah.
So what would you say to that, Vladimir?
You know what? Maxwell equations, it's a classical equations. You cannot talk about any particles in frames of Maxwell equations. This is the very first point. Maxwell equations, classical physics. You should have ensemble of some particles, and only then you can introduce these equations and follow them. This is my point. That's why. As for the particles, it should be quantum physics. It should be some different approach, different equations. And I'm not expert in this business. I cannot tell you what is going on with particles. But what is important? Plasma.
In quantum. Who's that by, Denny?
Eric Reiter.
Oh, I know. Yes, that's Eric Reiter. Yes. Yeah.
And this is a book about quantum physics, correct?
No, it's a book about why quantum physics is wrong.
Yeah, exactly. He talks about loading physics, doesn't he, or something?
Yeah. Let me get this in so you can see it. It's a threshold theory rather than a quantum theory of matter. So here again, you're using quantum theory a little bit, and that too seems to be not quite correct.
I'm very sorry. I don't have a comment. I don't know what to answer.
Okay. Well, there are a few other articulations, and maybe worth coming back to those at a later stage. So thanks for raising those points, Denny. I think there are alternative views. So thank you very much
for me misunderstanding. Maybe I'm wrong. My English not enough to understand what your question is.
Look, there are varying theories, or as many theories as there are people present here. We're not all going to agree on everything, but there are some fundamentally different theories, and Denny has mentioned a couple, the capacitance theory.
Well,
is it a classical theory or quantum theory?
It's probably classical, isn't it? Morton sphere.
Ian, Maxwell's equations aren't right for plasmas. You realize that?
For particles?
They'd need modification, certainly, or they don't.
Yeah, they have to be revised. Yeah.
Plasma. Yeah. Okay, well, I think
No,
that's
no,
something.
for me, it's absolutely wrong. We cannot use Maxwell equations for one particular particle. We
Well, you
cannot.
probably agree on that because for different reasons, you're not using Maxwell's equations.
Yes.
We're running out of time, and I did promise I'd let Nick in. So if we could sort of leave that conversation there, thank you very much,
You're
Dennis.
welcome.
And so finally, Nick, the last comment must be yours because we're running out of time. But please go ahead.
Well, cosmology, by its nature, is an absolutely huge topic. And I'm thankful for Vladimir, who has talked about all this new empirical data over the past several decades, as well as pointing out where the empirical data does not match accepted theory. And he's come up with proposing a new paradigm, and with just a few basic concepts like volcanic rotational fission, has explained a whole lot of this new empirical data that clashes with the old paradigm. So thank you very much. And this is like getting a college course or a postgraduate course in cosmology. So thank you, Professor Vladimir. Very much appreciated.
Thank you very much for your comment. Thank you very much for all the help you've done for me.
Yeah, thank you.
And by the way, I did mention that the term dark matter would come up with a lot of resistance from the CNPS. And
yes.
And
so
I'm glad that you changed that.
Yes,
because it's not audience were not good. It was my definitions were not good. They were obsolete. Dark matter was obsolete before satellites, telescopes, and all this stuff outside of the Earth. Because when we can see with eyes only, you can see them dark. But now it's a new era of astronomy, and I have to modify it, only name the concept of, instead of dark matter, you see matter. That's it, simple like
that. By any other name. And if it causes less confusion or conflict.
Yes, because it's a less confusion. And only because of your comments and very good questions of Harry, I've done this first page. I'm so happy. This is a very good result of my previous 4 presentations. You know, at last I gave these particles the right name.
And you're quite happy to have comments expressed in a strong form because they're more immediate, you know. So you're quite happy with that, and you're very flexible.
Yes,
so
I'm very happy about that.
And so regarding Dennis's comments, Vladimir himself has said that you know, when you have a paradigm change in cosmology, to expect him to have crossed all the T's and dotted all the I's, he calls for other people to come in and work on, enhance this theory.
You're absolutely right. It's exactly my intention to give this presentation and to initiate people to do something following these ideas, because it's a model, it's not a theory. It is a basis for new theory.
All right.
Thank you, Vladimir.
And thank you.
Thank you very much.
Thank you, and good day to you. And thanks for the contribution. Now, Vladimir, just it's my duty to give you a last moment or two. If you want to say anything else that you haven't covered or anything that's arisen from the recent conversation, and then I'll officially close the meeting. I think that's the normal situation. So the floor is all yours for another minute or so, if you wish.
Thank you so much. First of all, what I would like to tell, thank you so much, people, for coming, for asking questions, their comments, because it helps me to understand my own model more clear, to clarify even the notions, the concepts, and all the stuff, what I've done this time. The second very important point, it's very difficult, even for solar system, to put all what I know, what I've done, what I explained in one presentation. It's very difficult for me task to generate some main ideas of them. One of the ideas in here in this particular presentation, that all the theory of sun's generation energy, power, is absolutely wrong. I invite astrophysicists, experts in solar physics, to see a new picture of it. Because as I told you, the power density inside of, even in the center of our sun, is so low, like a compost pile, like a metabolism of virus, and so on and so on. That's why all the thermonuclear reactions, they are not right, unfortunately. We should not only change our classical physics, we should change even our view of all these astrophysical models, theories, how they really work, how to do these volcanoes, how to do this, how to generate these gamma quants out of the sun. It's only one issue. Next time I will tell you how many phenomena, how many issues we have with our Earth, but it will be next presentation. That's why my main objective is to initiate audience, physicists, to start thinking about in a different way, thinking about how he can be a part of this new cosmology and astrophysics. And I invite all the physical community to be part of the development of new cosmology, and through the new cosmology, new physics, and not only classical physics, but quantum physics, as Paul Wiener, my father, scientific father, proposed in 1937. It's time for all of us to start new job, new excitement about physics, and it will be a new era, not only in astronomy, but in the classical and quantum physics also. Thank you so much, and I will see you in 2 weeks with Mateusz.
Well, thank you very much once more, Vladimir. I think it's always very illuminating at the end of one of your presentations, and it's quite intriguing the amount of work that you have done. And you know, one never tires of getting more information. And in fact, in line with what I said at the beginning, and indeed what Vladimir validated later, that he's sort of moving down from the major to the minor. And today we've dealt with the solar system. It's quite amazing how many aspects of the constitution of the solar system can be described or explained in terms of WUM. But next time he'll be actually dealing with the Earth. So we'll be coming right down to the Earth, and we'll be able to talk about things like volcanic and tectonic eruptions and all that sort of thing, and why the Earth is constituted, and how it was formed, and in the solar system, and so on, and its common orbit with the sun of the Berry Center and all that sort of thing, I dare say. So we look forward to that. And again, everybody, please keep an eye on the announcements. And I know you're all very punctilious in doing that, because we're getting a lot of regulars reappearing. So I'd like to thank everybody in Facebook and in YouTube for having participated today, and for your excellent questions, and for your discussions as well, which we found quite illuminating. And indeed, everybody in the green room, we had 4 or 5 people in the green room today, and I think most of you spoke. Unlike the last time, we ran out of time, but today we had contributions. So I'd like to thank all of you in the green room for the contributions. And of course, the most important thing is I must thank Vladimir once again for having taken considerable trouble to get up in the Sunshine State at the west coast of the United States at 7 a.m. You're all talking about good morning, To me, it's late afternoon, coming to evening soon, and for having made sure that he has a written exposition of his lecture, so he can go through, and that's a job in itself. I mean, if there are any major errors, he'd have to correct those. So I'm sure he's done a lot of editorial work and so on. And we have 3 more parts still to go, part 6, 7, and 8. So the next one will be part 8 with a break for 1 week, fortuitously, because of the way we're organizing these tours. But I hope that gives you time to ponder on what Vladimir is going to say, and maybe have some ideas about how you might want to question him with regard to application of womb to the Earth itself. So I'll leave you all now. I'll again wish you a very good day, whatever part of the world you're in. Thank you very much for your assistance, and thank you very much for helping me with all your questions and clarity. Thank you, Vladimir, once again. Goodbye.